Understanding integrals. What is an integral? An integral represents the accumulation of quantities, such as area, volume, displacement, or total change. In simple terms, it helps us find how much of something is collected or added up over an interval. Mathematical notation is given as integral from a to b f of x dx, where f of x is a function, and a, b are intervals. To understand the concept, let's see some real-life applications of integrals. Example, finding the area. Under a curve, scenario. A farmer wants to calculate the total land area between a curved boundary and a straight road. The shape of the land is not a proper rectangle, it is curved area. To find the area, we consider small rectangles. Consider this is x-axis and this is y-axis. We want to find the total area between the curve and the x-axis from x equals a to x equals b. To find the area, the x-axis is divided into tiny strips. Each strip is a rectangle width, height y or f of x, and width dx. The area of one rectangle is area equals to f of x times dx. To get the total area, we sum up all the rectangles using an integral, that is, a equal to integral of a to b f of x dx, where a and b represents the boundaries. Total area equals the sum of all rectangles. Integral adds them all up. Now let's zoom in to observe the area under the curve calculated using rectangles. Have you noticed how they don't fit the curve perfectly? Now let's reduce the width dx smaller. Draw smaller rectangles to cover more accurate area. Have you noticed how the rectangles approximate the curve better? As we make dx smaller, the rectangles fit better under the curve, and the total sum gives us a more accurate area. In calculus, integration allows us to shrink dx to an infinitesimally small value, giving the exact area under the curve. So, for large rectangles, we calculate approximate area, which is inaccurate. For smaller rectangles, the area is more accurate, which is the better fit. Hence, tiny dx is the perfect area calculation using integration. Thanks for watching.